Welcome, everyone. I'm Penny Lewis, Ecological Landscape Alliance Executive Director, and I'll be the moderator for today's program, Engineered Soils for Permeable Pathways. This is part of our Focus on Sustainability webinar series, a series developed by a group of organizations known regionally for their quality ecological education. By collaborating on these webinars, we expand the reach of our programs beyond regional audiences across the country. In case you're not familiar with our organizations, they're all nonprofit and largely volunteer groups in the United States. The regional groups are the Ecological Landscape Alliance, the Chesapeake Conservation Landscaping Council, the Midwest Ecological Landscape Alliance, and Eco-Landscape California. And now I'd like to introduce our presenter, Tony Will. Tony has more than 35 years in the industry and is responsible for product development and marketing at Read Custom Soils in Hingham, Massachusetts. Read manufactures soils for a wide variety of applications, and today Tony will share information about engineered soils for permeable pathways. Welcome, Tony.
And thank you all for tuning in. I appreciate the work that the ELA does. I've been a supporter of theirs for years, enjoying the programs that they run every year at their conference, and this is a great opportunity for me. I always look for these opportunities to get out and meet with landscape architects, engineers, folks involved in the sustainable development movement to tell them more about what we do. That's how I looked on the occasion of my daughter's wedding 2 years ago. And I am, as Penny just said, with Read Custom Soils. We are an engineered soil blending company, precision soil blenders, a division of the AED Makepeace company, which is a interesting old family business that is one of the largest cranberry growers in the world. And they own a significant amount of southeastern Massachusetts and have really wonderful reserves of fine sand, good sand for golf courses and sports fields, which was our introduction to the engineered soils business. And in recent years, we've added a variety of niche soil markets that are listed here. And many of these are products that are aligned with the low impact development concepts, products that help to manage stormwater runoff, products like lightweight soil for green roofs, bioretention soils, rain garden soils, and some permeable surfaces such as fiber reinforced soils where you can do a grass fire lane or turf parking area, and also stabilized stone dust. So we're going to focus on this final topic today, stabilized stone dust, and I'm largely going to limit my comments to the two leading products, the two leading binders for stabilizing aggregate. They're called Stabilizer, made by Stabilizer Solutions, and Organic Lock, which is manufactured by a company called Envirobond. There are other soil binders in the marketplace. There are polymer sprays, there are resins, epoxies, there are waxes that can be added to fine aggregate. But the focus of this webinar will be really these two binders, Stabilizer and Organic Lock, which are nationally available. They're tested, and I believe they offer a cost-effective solution for a variety of applications. So what are we stabilizing? In a nutshell, it's a fine, durable, crushed aggregate material, generally 3/8 inch or minus, maybe 1/4 inch minus. In the Southwest and other parts of the United States, this material is a naturally occurring material called decomposed granite, or DG for short. In New England, there is no decomposed granite occurring here, so the local equivalent in New England is coarse stone dust. These materials, DG or coarse stone dust, going region by region, you'll find it available in different colors, which is nice for adding some interesting aesthetics to a job site. The reason that we can talk about DG or coarse stone dust interchangeably is that these materials have largely the same gradation. So what is gradation? Gradation is the particle size distribution for an aggregate as determined by sieve analysis. This graphic shows a pie of aggregates, which starting at the bottom are perhaps 3/4 of an inch and then going all the way around counterclockwise all the way down to the very fine powder. So the gradation of any given sample is determined by, in a lab, using sieves, testing sieves like these ones. Those sieves are stacked up with the largest screen openings at the top of the sieve stack and the smallest at the bottom. And then a sample is placed in the top, the sieves are shaken, and then the contents of each sieve are taken out and measured to determine the gradation distribution of how much material was retained on each sieve. Looking at our two stabilizer or soil binders, this is from the specifications from Stabilizer Solutions on the right and Organic Lock on the left. And what we see is specific or recommended gradations for the aggregate or the material that we will use these stabilizers in. So they both they're fairly similar, and what they are calling for is a fairly well-distributed, well-graded material with particles in the whole range of sizes from 3/8 inch down to the fines. Why is gradation important? It affects stability. If you have a well-graded material like the little graphic on the left, you have a whole variety of particle sizes. Large particles are fitted together with medium size and small size particles. So you have a very sort of stable structure by virtue of the fact that we have all this contact between all these different size materials. The middle graphic shows a poorly graded sample. This would be, for example, an entirely 3/4 inch stone, which only contacts at a few points and doesn't have a great deal of stability. Gap graded materials, I don't know that they commonly occur, but gap graded materials do offer some reasonable stability, but there is a chance of segregating the fines like the sand from the 3/4 inch stone. So the right-hand sample is gap grading. We generally are looking for well-graded materials when we talk about stabilizing soils and also in creating a good stable base. So what do we mean by stabilized? In the context of stabilized DG or stabilized stone dust, we're talking about binding fine materials together to provide a firm and stable surface. Basically, that's the definition of an ADA compliant surface, is a firm, stable surface, and that's largely what we're going after. We're looking for the general objectives of stabilized soil or stabilized DG pathway are to create a natural looking pedestrian path, again ADA compliant. Importantly, it's a pervious surface. It is permeable to rainwater. It has a water infiltration rate probably in the range of 1 inch or less than 1 inch an hour, but it's still pervious. We want a surface that doesn't require a great deal of maintenance and that offers us good long-term performance. Now, coming back to the question of what are we using to bind these aggregates together? Stabilizer Solutions is the original stabilizer. It was developed 25 or 30 years ago by Stabilizer Solutions out of Phoenix, Arizona, and it is largely psyllium powder. It's a seed husk from the plantago seed, and this is a natural gelling agent. So we have a 100% natural material in Stabilizer Solutions stabilizer powder. Organic Lock is a newer entrant into this market. It also has psyllium at the base of it. It has additional components, some of which are proprietary, but it has a concrete component, hydrated lime and sodium carbonate. It provides some different properties which they offer as improved strength to the stabilized soil. The psyllium powder, I just threw these slides together this morning because I wanted to give you a graphic idea of how psyllium powder behaves. Almost behaves like a hydrogel. Here's a half a cup of water. There's about a tablespoon of stabilizer powder. In it goes, stirred it up, and within 2 minutes, the spoon would stand up in the middle of that thickened gel of stabilizer powder. It is actually quite, I believe, quite the same thing as Metamucil, what you stir in your orange juice to get more fiber into your diet. That's psyllium powder, and so it has health benefits as well, although I'm not going to go off on that tangent. Now we're going to look again at some of the specifications. Both Stabilizer and Organic Lock provide detailed specifications on how their product should be used. That includes how the base should be prepared, how the material should be blended, how they should be installed, how they should be compacted. The two excerpts we're looking at here are from the Stabilizer and Organic Lock specs for preparing the base. And the base preparation is crucially important to the success of a stabilized aggregate pathway. And these specifications read somewhat similarly, and both of them are looking for a material that can be well compacted to create achieve a 95% proctor, which is a field test for compaction. The Stabilizer Solutions literature says that the suitable base material for a path will be, quote, your state's DOT recommended crushed granular road base. Organic Lock's language is similar. They call for a crushed granular road base, such as a 3/4 inch minus, and this is what's pictured in both of these images. Here we see the uncompacted material on the left and the compacted material on the right, and both, as I said already, ask that you get a high proctor, 95% proctor density test. Now, how do we blend stabilizer powder or organic lock powder into DG or into Stonedust? Well, these are some methods that are not recommended in the manufacturer's literature. They specifically say that bucket blending, simply measuring out a few tons of Stonedust or DG and adding the prescribed amount of powder, which in the case of stabilizer is 15 pounds per ton, and in the case of Organic Lock is 34 pounds of their powder per ton of Stonedust. At least that's based on the materials that we've submitted to each of these manufacturers. These are the recommended blend rates they provided to Read Custom Soils. But the idea of using a machine to simply bucket blend those materials together and then deliver it to a job site is not a recommended method. Similarly, the literature recommends against using a drop spreader or applying stabilizer powder to the surface of a Stonedust walkway and rototilling it in. The bottom line is that it's really difficult to blend materials successfully on a job site. It's very difficult to get the powder evenly distributed throughout the Stonedust, and it's very difficult to get the hydration or the moisture content correct. So in both cases, the suggestion from both manufacturers is that it's preferable to mix the Stonedust and the binder, they say, at the quarry or at a blending facility. The way we do it at Read Custom Soils is with front end loaders that are equipped with bucket scales so that we can accurately measure out a quantity of Stonedust that's going to be blended with binder. Here's an example. I'm not exactly sure of the quantities, but perhaps that's 20 tons of Stonedust, and the prescribed amount of the binder has been, the number of bags have been counted and opened up so that we have the correct percentage of binder on top of this pile. Next, it is mechanically blended or bucket blended But this is only as a pre-blending. This is a first step towards blending the materials together. We use a Pug Mill Mixer, which is one of the recommended pieces of equipment for getting a really thorough blend of the powder and the crushed aggregate. This is what the blending chamber of a pug mill looks like. It's a set of shafts with paddles on them, which spin at a high speed and furiously mix the powder and the stone dust together, so that when it comes out the discharge and goes up the conveyor belt, it looks completely uniform. We also add some moisture to it as it exits the pug mill. So we add a little bit of moisture to, because these binders are a water activated product. Stabilizer and Organic Lock also approve of the use of some other blending equipment. The Dakota Blender is one of these approved. Paddle mixing plants has bins and that deposit material into a blender and then out a conveyor. Small batches of stabilized stone dust can be prepared in a cement mixer. Larger batches can be prepared in a cement mixing truck, which would then also rotate it together. The end result, the goal of this blending, is to have an equal and even blend of stone dust and stabilizer powder, organic lock powder, with the correct amount of moisture in it, so that you can make a ball that just barely holds together. A ball that you can squeeze water out of is too wet. So it's the simple field test is if material is delivered to a job site and you're curious to know if it's ready to go, you just pick it up and see if you can make sort of a snowball with it that just barely holds together. Whoops, I'm sorry, I'm skipping ahead too fast here. Sorry. Okay, installations that succeed are installations that have been designed with stormwater runoff in mind. The goal is to get rainwater off of a stabilized path. You don't want to have water channeling along a path. You don't want to have it puddling on a low spot. You want the stormwater to get off the path. Installations that succeed are built on a well-compacted base. As I said already, both manufacturers emphasize the importance of a very well-compacted base, and that is a hallmark of a successful installation. It should be approached just the same way as if you're building a driveway or a road. Installations that succeed are properly compacted. Both Stabilizer and Organic Lock recommend the use of a heavy static roller. Not using plate compactors are not recommended. You want to have the static roller not in a vibration mode. Vibration or the motion of a plate compactor tends to create some segregation where the finer materials will come to the surface of the pathway and the coarser materials will descend. So we are trying to roll the finished product with a heavy static roller. Both of these products have weather limitations. They should be installed during generally warm and dry conditions. They cannot be installed during rainy periods or when the temperature is 40 degrees or heading lower. Here in New England, we've just entered a cold snap this week, and we're suddenly seeing a forecast which for the next 8 or 10 days doesn't have any temperatures, temperatures drop below 40 each day. So we're pretty much at the end of the season for stabilized stone dust installations in New England, unless we get a warm snap late in November. Successful installations also receive some limited degree of maintenance. If it's possible to get leaves and organic materials off of a stabilized path, that's helpful. If there's a low spot on a stabilized path, it should be fixed. These materials are quite forgiving. They can be rehydrated at any given time. That is, they can be, water can be sprayed on an area, a low spot. It can be scratched up with a metal rake, and additional stabilized stone dust can be added to that area that's been prepared and scratched up, and then that area can be recompacted. But low areas, just like a gravel driveway, a low area will continually get soft and begin to rut out. So I'm going to spend a little more time just talking about these techniques for getting stormwater off of a stabilized pathway, because they are so important. The actual surface of the stabilized pathway, there's a choice to be made about how we're going to grade that surface to help stormwater get off of the surface. Perhaps the most common treatment is to crown the surface of the pathway, so that stormwater that lands on it is going to shed off to the left and off to the right somewhat evenly. And this works well on installations that are essentially on level ground. The next item down, we see a side slope to the area. We see our blue Stonedust pathway has been all pitched in one direction. That's a cross slope. And in this case, it's actually a outslope, meaning that the stormwater runoff is going to be shed off in the same direction as the overall slope of the terrain and the area. That's an outslope. To get rid of the water, that's the most effective way to go. An inslope might be necessary on some job sites for grading reasons. This involves having the water hit the trail and then return back towards the hill, so to speak. And in this case, you'd really have to have a drainage ditch on that side to collect that storm water and begin to channel it away. The outslope is clearly a preferred way to keep that water moving downhill. Another technique that's used for designing a sustainable trail is including a nick. And a nick is shown here on the right-hand side of this trail design. And what they've done simply is create a grade reversal. So this trail, which might have followed the dotted red line from the right to the left, instead it has been built up to create a grade reversal, grade change upwards. And the nick is just the low spot on the side of the trail that provides relief, provides a place for that water to go and drain away from the trail. This photo I took last week out in Leominster, Mass, at a Trails Conference, the Massachusetts Trails Conference, sponsored by the Mass DCR. And this was through the Doyle estate in Leominster. And this trail has two nicks on the left-hand side of it. I don't know if you can see them or not. I'm going to draw in and show you exactly where they are. And they're quite subtle. They don't interfere with the appearance of the trail at all. But on the downhill side of that trail, there are these just lower spots where stormwater, as it collects and starts to move down that trail, will just be siphoned off, diverted away to the left. Very effective technique and one that could be incorporated in more trails for more successful results. An interesting resource for trail design can be found in a publication of the International Mountain Bicycling Association, who in 2004 published the Trail Solutions book. And some of these diagrams that I'm using today were taken from that book. They created a simple rule of thumb for trail design with an eye towards making a sustainable trail, called the half rule. And the half rule basically states that you have a side slope, which is the overall slope of the surrounding terrain. And the trail that is traversing that side slope should be less than half the grade of the side slope. So in the top diagram, we have a side slope at 20%. We have a trail that's fairly steep at 15%. And stormwater that comes down that slide slope and hits the trail is going to follow that trail down. And water that courses down or channels down a stabilized stone dust pathway is a problem. In the bottom diagram, we have a trail which meets the half rule. The side slope is 20% again. The trail has a 8% grade, and stormwater that comes down that side slope and hits that more gradual 8% trail that's properly outsloped, that water is likely to sheet across the trail and reach the downslope side without creating a real damaging effect on that trail. So I have about a dozen more slides, which are installation slides, but I would encourage anyone who has questions. This would be a good time to think about any questions you may have and type those in so that Penny can share those with me as we get towards the end here. Now we're going to look at some installations. Stabilized stone dust can be installed and frequently is installed by contractors that are familiar with putting down asphalt. They frequently do a pretty good job. They like working with this material. It's cooler than asphalt. It's easier to work with. This particular installation was early in the spring of 2017 in Cambridge, Massachusetts. Memorial Drive runs right along the Charles River. There's the Boston skyline on the right-hand side. And the crew here from Newport Construction is installing stabilized stone dust, part of a several-year project. There's thousands of feet of stabilized stone dust along the Memorial Drive. And you can see in the distance, at the end of the trail, the crew is there with the asphalt paving machine. And actually, just to the right of that, there's a dump truck. That's our delivery of another load of material for this project. This is stabilizer material that's put down and then allowed to set up in place. Stabilizer solutions product requires that it be allowed to set up for anywhere from 8 hours to perhaps as much as 72 hours if the conditions are sort of damp or cool. In this case, this material was allowed to set up overnight for about 24 hours, and at that time it can be rolled. Same project. This is them actually putting the material down. There's a slight cross slope, almost imperceptible, bringing stormwater that would hit that trail over towards those cobbles. This is a small installation of organic lock at Amherst College. In this case, the material is being carted onto the site by that track-mounted cart on the right-hand side. The base has been prepared and compacted with a plate compactor. The material is being brought in, spread around the structures there, and largely hand-tamped. They could not get a roller into this area. And hand tamping is basically the alternative approach. It provides a reasonable degree of compaction without the vibration action of a plate compactor. This is the new visitor center in Concord, Massachusetts at Walden Pond. This is an organic lock stabilized sidewalk that runs all along the front of the building and over towards Walden Pond. The upper left-hand corner, we see the installation crew. They're using a small sidewalk asphalt spreader. This job, interestingly, was done in two sections, one in last July and the second was in October. So in the intervening months, the color of the aggregate is from the quarry, and the quarry where we sourced this gray aggregate, the vein of material that they were crushing changed a little bit, and the color of the aggregate looked quite different. There was one section that was light, one section that was dark. It's natural variation, and in the end, everyone decided it was okay. But it is a consideration that if you need to have a project that has 100% uniform color from end to end, it might be necessary to secure the full quantity of stone dust or the full quantity of DG and set it aside so you don't have any color variation on a project. Again, this is a project in an environmentally sensitive area. It's stabilized stone dust. Conservation commissions and state and town groups really appreciate the fact that stabilizer is completely natural, organic material, non-toxic material. And in this case, this was a help to sell the job, let's say, to have a natural material going in very close to a pond in a water resource area. This installation is again being accomplished with a sidewalk spreader. The detail that I like here is there is no edging system on this project, and the installers are tamping a 45-degree angle on the side of that profile, which is approximately 3.5 inches, maybe close to 4 inches. It will compact down about 15% when it's rolled, and wind up with a completed compacted depth of about 3 inches. So they have a nice 45-degree angle that they've established. It creates a nice strong edge to the pathway, and then that loamy material will eventually be raked back over the 45 to be in contacting right at the grade at the top of the pathway after it's compacted. This is an installation at a golf course in Hingham, Mass, nearby. Quite a steep installation of organic block, probably in excess of 15 degrees slope. And this is a type of project that seems well suited to organic block. The real challenge with this, any installation, and particularly one where you have a steep slope, is the drainage. Where is the water going to go? In this case, we do have a cross slope heading to the right-hand side from that the left-hand picture. It's heading off to the right. A nick should be created there, really. Looking at that photo now, it would be ideal to create a low point for that water to get right off. Otherwise, it could channel down the right-hand side of that trail. One difference in installation between organic lock and stabilizer is that organic lock, the material is also water activated, but it does not use as much water as stabilized stone dust. So the material can be put in place and then immediately compacted. There is no setup period for that material. This is another organic lock job. This is owned by the Massachusetts Department of Conservation and Recreation. It's a rail to trail conversion project, and just an absolutely beautiful wide 8 or 10 foot wide path that they've created through the woods in this abandoned railroad. The organic lock, as I just mentioned, can be rolled immediately, so not far behind the asphalt paving crew, we find a good-sized, heavy 3-ton roller, which is immediately finishing that surface, so it's smooth as can be. Installation from last year. This was another Department of Conservation and Recreation project at the Rumney Marsh. I believe that's Everett, Massachusetts. This is the way the material looked after it came out of the asphalt spreader, while it was setting up and before it was compacted. It looks like it may have been compacted, but this is really just the smooth surface that comes off of the asphalt spreader. This project would be rolled on the left side and right side first to kind of squash down the sides to create that crowned effect. It's a fairly level job site, so the best strategy here will be to just get rid of the water off to the left and right. It looks like a fairly decent draining soil. The Minuteman National Park in Concord and in Lexington, Massachusetts, has used a lot of stabilized stone dust for years, and it provides this, really ideal pathway. Has a very vintage or old world look to it. 100% natural, nice crunch underfoot, low maintenance, and very appropriate to a historic national park like this one. At the other end of the spectrum, we go to the Partners Healthcare facility. It's a new LEED building in Assembly Square in Medford, Massachusetts. And they've put a stabilized stone dust pathway in their courtyard. This is a building that also has green roof sections and lots of modern low impact concepts at work. Beautiful stabilized pathway all throughout their courtyard area just outside of the lunch facilities. Beautiful installation. This is organic lock that was installed at Novartis. This is one of our first organic lock projects that we did a couple of years ago. And in a courtyard behind this iconic new construction building right next to MIT on Mass Ave in Cambridge.
Excellent. We have several questions for you. What is the steepest slope that is recommended for stabilized soils on a pathway?
Well, I think, it's a good question. I think that as a general rule, a pathway that's 10% or more is going to be more and more of a challenge. However, if a pathway can be designed so that the stormwater is really well managed on the site, if water is diverted at every opportunity away from the pathway, it would be possible to install a steeper pathway. I showed you the one in the golf course, which is over 15%. And I think that it's really more a function of stormwater drainage on the site. If that can be handled, and if the path is set up in such a way that stormwater is not going to be channeling down the path, then that you could have a 20% slope. But there are other factors that go into this. It's what kind of traffic is going to be on it. Is it pedestrian traffic? Is it light vehicular traffic? Is it lots and lots of passes per day, or is it occasional? So it's a difficult question to answer, but the real point, the real takeaway is that it has much more to do with how stormwater is allowed to interact with that pathway. If we can keep the stormwater at bay, then the pathway should stay firm and stable at a significant pitch.
Okay. Next, follow on to your comment about vehicular traffic. Can a stabilized stone dust path take the sort of traffic that municipal maintenance vehicles would require?
The answer to that, I think, has a little bit to do with the quality of the installation, but really in New England, in our environment, in our freeze and thaw and winter and snow plowing and all the things that go along with installations of materials in the Northeast and actually, all across the country at these latitudes and areas where you have a lot of weather fluctuation, you shouldn't expect these materials to behave like asphalt. That said, we compare notes with our friends at Gale Materials and one or two other soil blenders in different parts of the country. And I know that they are using stabilized stone dust and organic lock stone dust to build full-on residential driveways and driveways that are taking a lot of heavy traffic. It is not something that we've done in New England. We have recently done an area behind a historic building, a bit of a test strip, a good heavy installation of organic lock, 4.5 inches deep, and it will see some light vehicular or medium vehicular traffic, some maintenance vehicles and some mowers and such. I'll be watching it closely. It's not far from this office, but we're cautious about overselling any material. And for New England weather and for areas where there's a lot of freezing and thawing, I would probably shy away from using stabilized aggregate as a permeable driveway. I think in these areas it should be used for pedestrian traffic, pathways, and the occasional vehicle. The maintenance vehicle can certainly drive up and down and take the trash away and such, but I'm not sure I'd want to have vehicles actively turning and braking on top of the material. These products have a tendency to rehydrate or take water back in when it rains. And if you have a period of extended wet weather, then a installation of stabilized stone dust will become entirely rehydrated or re-wetted. And that means it's going to be back in that condition that it was in when it was first delivered. Not that it's going to be that loose, it's still compacted, but it will become pliable. It'll feel perhaps like live rubber underfoot. It'll have a little bit of bounce. So joggers and runners will love it, but it could be more prone to getting some damage if a vehicle were to drive across it and turn sharply.
Okay, thank you. We have a couple of other water-related questions. One is, when is water added for the activation of the material? Is it added on site? And if it's added beforehand, how long before the material hardens?
Good. The manufacturers in both cases, and I think that just the best practice might be that it's best to get the material delivered to a job site all pre-mixed and pre-hydrated, ready for installation. When we add water to it at our manufacturing facility, we're completely blending the powder with the stone dust in a dry condition. Then we're adding a small amount of moisture to it to water activate it. The stabilizer product, the stabilizer product, you really can't overhydrate it. It will take a lot of water. The organic lock product can be overhydrated, meaning that you can add too much water to it and it becomes very soft and unstable. It's a tricky thing. So adding the correct amount of water at the job site, again, I find that to be a real challenge, and that's why I think the recommended preferred method is to get it all mixed and hydrated from a blender who knows how to work with this material and deliver to the job site that way. However, I do know that some stabilized stone dust or stabilized DG manufacturers will blend the material, blend the aggregate and the binder, and put it in super sacks and ship it all over the country so that it arrives at a job site essentially in a dry condition, and it needs to be hydrated or wetted before it can be installed. And that's something which I would like to see the written instructions for that, but it would be something you'd have to do very, very carefully. With Stabilizer Solutions product, you could actually be fairly aggressive, add water, flip it around with a bucket, with a bobcat or a small machine, and get it all wetted, and then put it in place and allow it to set up for a day or so. With organic lock, it would be a little trickier to get the moisture right because it gets to a tipping point where the moisture, where you can just make that ball, that snowball of organic lock stone dust, where it just barely holds together. However, adding another 5 or 10% moisture to that stockpile will cause it to kind of go a little bit too far and get very, very soft. And a lot of things, it's not as though you can say, we need to open up the super sack and add 11 gallons of water. It's impossible to make that kind of objective or very specific recommendation for the amount of water that's required, because these materials react to humidity in the air and they react to weather conditions, such that a stockpile of stone dust that's stored outdoors will have in it perhaps 10% moisture just naturally retained in the stone dust if it's been raining and it's been damp recently. So in some instances, we've even found when we're blending organic lock, which requires much less water for activation, we can add the organic log powder to a stockpile of stone dust that has just been sitting out in the ambient air and run it through our Pug Mill Mixer, and it requires no additional moisture added to be ready for installation. In other words, it's just used all the available moisture in the stockpile. So it can be done. It's just tricky to do it on the job site. I think I answered the first half of the question. I'm not sure I answered the second half.
All right. Well, that sounded good. The next is a comment and a question from a listener. It's the stabilized stone dust this person has worked with, when it's wet, will rut and deform. Any comments on how to counteract that effect?
Well, again, when we look at the manufacturer's recommendations, their specifications for installation for stabilized stone dust stabilizer brand are to, it's water activated, it arrives like wet material, it gets put in place, it's still very pliable, it's very soft. You can't walk on it without leaving significant footprints. That's the way the material is when it's properly delivered, the stabilized stone dust. It needs to set up for a period of time, at least 8 hours, perhaps as much as 72 hours. And what's happening really is that material is drying out and solidifying, getting firmer. I showed you the slides that showed what happens when you add water to psyllium powder. All of that gelling is occurring inside of that slab of stone dust. And as it dries out, all of that strength is, it just helps to glue and bind everything together. So the fact that there are footprints or it's a little bit sloppy in the early going is pretty much the natural condition for stabilized stone dust. It needs to be allowed to set up for a period of time. Basically, you need to allow it to set up until you can walk on it without leaving footprints, and at that point it's fairly firm. Now it's ready to be rolled, and even then recommendations from the manufacturer suggest that the pathway, when possible, just be roped off for another day or two to allow it to get to its full cured, dried strength. So these things do take a little bit of time to achieve their full hardness.
Okay, the next also has to do with water. If the path is properly installed and has proper stormwater management throughout the project, is it accurate that there will not be surface degradation over time as water moves across the path?
Yes, when water sheets across a stabilized stone dust pathway, there's no particular change to that surface. The surface of a stabilized pathway, however, always features a loose layer of aggregate, loose layer of fine particles. Just the way it doesn't stay as tight as concrete. And that loose surface is certainly very abrasive, and it is potentially a material that could track. This is something I didn't mention, I meant to. When you have a stabilized stone dust pathway close to a building, it should be at least 20 feet away from the interior of that building. You want to have a distance from the stabilized stone dust pathway or stabilized DG pathway into the building. If you have 20 feet to walk off, you're going to lose most of the fines that might be tracking on your shoes. So it's not great. You can't really butt it up to a building, particularly a building with hardwood floors. You're going to be tracking some very abrasive material in. But going back to the path itself, a path that's heavily used path that has the commonly what you'd expect to see, which is this loose layer of aggregate on the surface, this abrasive material. That surface is sort of, I don't know if exfoliating is the right term or not, but it's gradually working down over the years. You have perhaps 3 or 4 inch profile of material, and the top surface of it is loose and just gradually working down. These paths properly installed are going to be there for 10 or 15 years performing well. and they can be quite easily repaired. Certainly the organic lock literature talks a lot about the self-healing qualities of their product, their binder. So these materials, with a little bit of maintenance, you can expect good long-term performance. But again, going back to the original question, the stormwater runoff really shouldn't be a damaging effect. It's that stormwater is being sucked into or absorbed by the stabilized pathway to some extent. That rehydration of all the gel material, the binder, helps to hold everything together. So really, the stormwater has, in effect, it's helping to glue everything back together again.
Okay, this next question has to do with the pervious nature of this material. What is the runoff coefficient and what percentage is infiltrated?
I don't have that answer right at my fingertips. I'd be happy to reply to an email from whoever has that question. We did. I mean, the simple answer is we see infiltration of probably just less than an inch an hour, and the infiltration is affected by the base under the stabilized stone dust pathway. So if the base has poor drainage characteristics, that's going to negatively impact the permeability of the whole system. But it provides a pervious surface. It's important for doing a calculation of how much impervious surface area you're creating. It's nice to be able to have a pathway that doesn't add to that equation. However, I can't answer the specific question. I would reply to an email on that.
Okay. The next is about precipitation in the frozen variety. What is the recommended strategy for snow removal?
Well, I think the simple answer, I suppose, would be a snow blower is better than a snow plow. When a pathway freezes frequently, it's freezing with a significant moisture content, just as winter weather is prone to be kind of wet. And a path that freezes with a high moisture content is basically going to be a block of ice, or not literally, but it'll be very hard in that condition. So a snow plow probably, again, it's hard to generalize, but under a lot of conditions it wouldn't be a big problem. When someone snow plows a gravel driveway, they would typically drop a snow blade down to the ground, then lift it up 1 inch just to prevent peeling the gravel off the driveway. So a similar approach would certainly be a good practice to, prevent any real damage to a surface. But a snowblower has little skids on either side of it that you can adjust up or down. And if those skids are adjusted downwards, you can just stay up off the surface again an inch or a half an inch, and you'd have no contact with the stabilized pathway whatsoever. And that would be a good way to clear snow.
Okay, thank you. Does the well-graded nature of the aggregate have the potential to reduce pore space and therefore permeability?
Yeah, it certainly does. And every sieve analysis that we get for stone dusts that we submit to Organic Lock or to Stabilizer, the percentage of fines contained in a stone dust sample or a DG sample will vary from source to source. And those stone dusts that have a higher percentage of fines, well, actually, if the percentage of fines exceeds the manufacturer's recommendations, then that material is not going to be used. But if we're looking to optimize or maximize stormwater infiltration, we would want to find an aggregate that has the lowest acceptable range of fines. So we would go back to that recommended gradation from Organic Lock, or the gradation recommended by Stabilizer. Look at the fines, look at what's allowed to pass the 200 sieve. And we would find, for example, in our operation, we have 6 different colors of stone dust that we use. And those 6 stone dusts all have slightly different gradations. They fall within the ranges that are acceptable by the binder manufacturer, but they are all individual. And again, if we were looking to optimize the stormwater infiltration, we would pick one that had the lowest percentage of fines.
Okay, so you mentioned one of the questions that we had was about a source for colors for the aggregate, and you mentioned colors. The follow-on question is, can you roll other aggregates into the surface during installation for varied visual characters?
I have not seen that specifically called out in the literature from either one of our manufacturers that we're talking about today. I have, however, seen interesting installations where stepping stones or flagstones have been incorporated into a stabilized stone dust pathway. Basically, they would be like a 3 or 4 inch thick stepping stone that was placed in the pathway, and then the stabilized material was put in and around the stepping stones and compacted. That made for a very nice and increasingly naturalized appearance. The idea of doing sort of an exposed aggregate finish makes some sense to me. Again, this is not a really robust binder. These binders are subtle glues. They're not a high strength 2-part epoxy. They're a subtle glue. So chances are, I think, fairly good that any aggregate that's pressed into the surface could pretty easily be kicked out of that surface later on. So I don't think it would be a long-term exposed aggregate appearance. I think if you were to embed some aggregate in the material, it would perhaps be somewhat short-lived, perhaps something that could be replaced, but it's unlikely to stay there for a long period of time just because the binder is fairly weak. We're binding together a very well-graded material, so we don't need that strong of a binder. We have, however, just to achieve different aesthetic appearances, we have blended different colors of aggregate, again, to sort of match other materials on the job site. So that's another possibility. And a final comment on that is that the stabilizer has one design for pedestrian paths, which is a 3/8 inch minus aggregate, and a more robust 1/2 inch minus aggregate design for vehicular traffic. So you can certainly add more of a coarser aggregate for a special occasion, for a special application, like if vehicles are going to drive on it, then having that larger aggregate makes for a stronger mix. So that'd be another way to get more visual variation into a pathway.
Okay. The next two have to do with hydration again. One is during a period of drought, do you have to apply any wetting to maintain the stability, or in periods of excessive rain, do you need to limit path access because it becomes unstable?
Yeah, these pathways achieve sort of their maximum strength when they're dry. So certainly excessively dry conditions are not a problem. That's when the path is going to really be as strong and stable and hard as it will be. Periods of extended rainfall, again, I think that what you'll see is a softer surface, the entire profile. If that entire 3 or 4 inch profile of stabilized stone dust has become hydrated, then all of it's going to be soft. It will be tightly bound together, but it'll have some give to it. So I think the experience will be more like a live rubber than really a muddy condition. That said, I'm familiar with our materials. I'm familiar with these coarse stone dusts that we use here in New England. I don't know if the DGs here and there, if they have more fines, more material passing the 200 sieve, they perhaps could become more muddy when wet. So based on the materials we use, I don't see a muddy condition or a condition that would require that you stay off the pathway. But it could be different for materials that have more fines in them. And I guess sort of going off on that point, one one aspect of stabilized pathways that's not really addressed very well is the annual maintenance. And I think it's reasonable to say that each springtime or each fall, it makes sense that you should just spend a little bit of time walking a stabilized pathway with a rake and a hand tamp with you, raking off leaves or organic debris, making sure that the pathway still has an open nick or an open area on the edge where water can get off, and hand tamping as necessary any areas where it looks like it's a little soft, just to kind of pound it back down again. So with a little bit of maintenance, you can get a very nice performance out of the material. We haven't talked at all about edgings. There are a whole variety of edging designs that are specified by Organic Lock and Stabilizer, using different types of metal edge or stone, like cobblestone edges or granite edges. And those edging systems add to the strength of the pathway by kind of giving it a nice bulkhead at the end. But they also can trap water on the path, so it can be a bit of a two-edged sword. It's another point of discussion, but again, that good design is going to have places where water can get off the trail. Whether there's an edge system or not, you have to have places where water can leave the trail.
Okay, we have several questions relating to the lifespan, how long each of these two products that you've talked about are expected to last, and what maintenance you might have to require if there's been any kind of root damage. But if you can just give us a quick overview, since we're coming to the end of our time, about longevity.
Yeah, and longevity is going to be the biggest factors will be how well it was built to begin with, how well the base was prepared, and how well the material was installed, how heavily the path is used. So if you have a well-built path that's hardly used at all, you're going to have, who knows how long that path will last, 20 years or so. A path that's well built and seeing heavy use and no maintenance may have a much shorter lifetime. Maybe it's 7 or 10 years. My estimate would be we're looking at materials that should perform well for 10 to 15 years. But there's so many site-specific conditions with drainage, variability of drainage, how much sunlight they're getting. There are things like irrigation, where you have an irrigation system that oversprays a pathway. Well, that causes that pathway to be softer a lot of the time. So there are lots of site-specific things that interfere with or affect the longevity of a path. But these materials, properly installed and properly maintained, should have a 10 or 15 year, I would think they'd be problem free for that period of time.
And a follow on to that, if there is an issue with binder failure, is there a way to restabilize the pavement, or does it need to be completely redone?
Yeah, now Stabilizer Solutions offers a spray-on product called Stay Lock Concentrate. It's designed to sort of renew and re-strengthen a previously stabilized path. So Stabilizer Solutions actually has a sort of follow-on product that addresses that concern. Organic Lock has a more I think their philosophy really goes more towards the idea of adding additional material in any areas that might require it, that their material is a fairly robust binder. There's more than twice as much of the binder in every ton of Stonedust or DG. So it's possible to go into an area that's, for whatever reason, damaged or needs any kind of work, and spray water on it, scratch it up, and add additional material, or even rework the existing material that's there, rework it, put it back into place, and recompact it. So they have sort of a self-healing quality that they tout. And I think that where they haven't got an add-on spray, an add-on product, I think you have the ability to work with what is already there, or import a little more new material and add it on top.
All right. Next two similar questions. One is about accessible to wheelchairs and the other is about bicycles and how either or both of them are affected when the product is wet.
I would say that the firm, stable goal is achieved whether the material is wet or dry. It's conceivable that under a period of extended wet weather that there might be small chair marks from wheelchairs. The wheels might leave a small mark. I think that a properly installed pathway with good drainage, you wouldn't even have that effect. I think that the rainwater would make no difference. Sorry, what was the other, wheelchairs, or what was the other question?
About bicycles after rain events.
Yeah. Again, I think that any bicycle tracks, if you were to see a perceptible bicycle track, I think it would be quickly compacted out by future foot traffic. In other words, it's not going to create such a noticeable rut that it would be a lasting feature. It would be people walking on these paths are just continually recompacting them.
Okay. How much time has to be left for the products after the rolling before they can be used?
Yeah, I think it's a good idea. I think both of them, the stabilizer is going to get rolled a day, on average 24 hours after it's installed. And then from then, I would say it would be wise under sort of reasonably dry conditions, it would be wise to cordon off that area for another 48 hours. Certainly the best test is to get on it and see how hard it feels. But I'd say just generally speaking, you want to give it 2 additional days to fully cure and get nice and hard. Organic lock can be rolled immediately. It feels very firm immediately. It also really deserves a day or two, probably 2 days, 48 hours, additional period just to get to full strength so that you don't have any heel marks. If someone's wearing cowboy boots, they might leave a few marks. But generally, these materials, when they're allowed to set up properly, will give you great performance.
Okay. The next is about cost. How does the cost of a stabilized stone dust path compare to asphalt?
In our market area, New England, it's actually quite similar. I wish we had a big cost advantage, but we haven't. We provide a significant amount of customer support on when a customer orders these materials. We have a representative of our company visiting that job site on the day of the installation or the delivery to provide coaching to the installation crew to actually inspect the base, make sure that it complies with manufacturer's recommendations, and we will provide any additional follow-on service that they require. So we do a lot of hand-holding, a lot of product support, and that adds to the cost of these materials. We are trying to create a track record of 100% successful installations. I know that there have been some stabilized stone dust pathways here and there around the country that haven't performed well, and frequently because of poor on-site mixing and a number of things that can go wrong. And at least in our market area, we make an attempt to provide enough support that we have completely successful installations everywhere we go. So the cost is rather similar when you look at the cost per square foot.
Okay, so part of your advantage is probably that the permeable nature is such that you can outcompete in some of the ecologically sensitive areas where they require permeability.
That's right. Yeah, we're offering a totally different aesthetic. It's more pleasing to look at. It's nice to walk on, a little crunch underfoot, variety of colors. So there are a number of things that it does better than asphalt, but asphalt is more durable, period, and we don't have a real cost advantage. So it's for folks that want to use another material, add a different texture to their environment.
Right. We just have time for 2 quick final questions. In ecologically sensitive areas, is there any other solution for compaction if they're not allowed to have static rollers in place?
Well, hand tamping, it's tedious. If it's a long path, it would be hard. But hand tamping is the clear option. Using a roller, a water-filled, like a lawn roller, that's only going to get you about 400 pounds. So that's really not an adequate amount of weight. We're really trying to get a 1-ton roller or better is ideal. So that's a bit of a challenge. It's the kind of thing that most of the stabilizer or organic block distributors will go out and look at that job site and see if there's any way to work around and make that more successful by, again, I'd say that if there's any way to get a roller in there, we would try to do it.
Okay. And the final question that we have time for deals with the Sustainable Sites Initiative, sometimes called LEED for Landscapes. Do you know if these stabilized Stonedust paths achieve points in that rating system?
They do. The aggregates that we're using are all locally sourced. They represent, 99% of the material is the aggregate. And the manufacture step is also occurring within 500 miles of the job site. So again, there's locally sourced and locally manufactured credits are available. I believe, well, I won't go into it, but there may be credits available for the fact that we're creating well, certainly a pervious service and a potentially cool service when light colors are used, but I'm not familiar enough with the LEED points system to go into that.
All right. Well, thank you so much, Tony. This has been very informative, Tony. Thank you so much for taking time to share this with us.
Thanks, Penny.